Hello.
How are you?
I'm good. How are you?
Good, thank you. What's new?
Um, so I took the practice test from Altius, and that was like pretty much the same as like my other ones. And
Which
then I
is? Um, yeah, I'm just looking at the full lengths tab in your spreadsheet. So
okay.
I don't know if you've updated that or not, but I see for the last test, Blueprint full length 6 on the 21st of April.
Yeah, I didn't update it. My bad. Sorry. I'm gonna update it now though. Hold on. And then I took my full length from what do you call it? The AAMC website. And I did not do that well. I don't know. It just has me a little
Mhm.
scared. But I'm not like too scared where I'm like, OMG, I'm gonna push my test back. I just feel like there's something that I might be
Mhm.
missing, but I'm not quite sure what it is just yet. So I've been reviewing like yesterday and today I've been reviewing my last full length. I don't know. I feel like it also could be because I took that test on a Saturday, like afternoon, and I was pretty tired. And I normally take my tests on Sundays, but I was running a race. Um, I ran a race yesterday, so I was like, because I was like, oh, I don't want to take the test after the race because I'll probably be tired. So I had like the day Saturday to do it. So I was like, let me do this on Saturday, but I don't know if that.
You had like a running race where you're running.
Yeah.
Oh, that's cool. Do you do like track and stuff?
Yeah, I used to do track in like high school and now I've just been like running to I guess like keep up with like my physical activity. And I don't know, it's just I enjoy it. It's just like a little challenge for myself every now and then.
Yeah, yeah, and that stuff really boosts your like cognitive abilities um from all from that type of exercise. Um, that's really cool. Do you do a lot of like sprints or is it more so like marathon stuff? Or
I started out doing sprints, but yesterday, like when I ran, it was a 10 miler.
Hmm,
So I
damn,
think I do like a little bit of both. Yeah.
that's
I'm
impressive.
excited
Hmm.
though, because I'm getting a little faster in terms of my mile pace. Like I think I was able to keep like a 10-minute, 15 mile pace for the 10 miler. So I was pretty excited about that.
Have you ever tested your resting heart rate?
Yeah, I normally have the Apple Watch. It's like in the 50s.
Yeah, that's remarkable. That's called athlete's heart syndrome.
Yeah.
And basically if you you know exercise that way, your left ventricle gets stronger and it can pump out larger volume per pump. So you don't need to, your heart doesn't need to beat as often. So that's really, really cool. This was Altius full length, which one? One?
The
Free one?
yeah, it was a free one, so it was like half. I feel like the timing kind of messed me up with Chem Phys. Well, and also their Chem Phys section was like a lot of organic chemistry. So that's why I was watching this one guy that was going over the organic chemistry like miles down sheets. So I looked at that after the test and then I was just doing like a bunch of like OChem practice questions throughout like last week. And I was pretty like surprised by my car score with that section. So I feel like the techniques that we went over the last time that we met that helped me with
Yeah.
the Altius car section.
Mm-hmm.
But and then I don't know. what happened for like biochem and psych soc. I'm kind of like surprised because my section, like the blueprint full length before was at a 127. So I was just like, just weird that I'm like not consistent in psych soc just because I don't know, I feel like I was before.
Yeah,
And then,
since that's the section that's the most content dependent, right? It could mean that things that you know on one exam that or things that you don't know on one exam that you then subsequently learn about may not be tested again for, a couple of exams. Um, but yeah, I think this is a good score. Now, um, there's something else happening here regarding the test that you just took, but I don't want it to interfere with, the next test that you take. So I'll give you more information about that. But a hint is that people call the free scored exam pulling five, right? But that is not what it's called. It's called, well, the free scored exam. And yeah, after you take your next exam, which will be like we're in phase three, right? Where we're just doing AMC stuff now. So
mhm.
after you take, your next test, maybe I'll tell you a little bit more information about it. Um, but okay. Okay. Um, so for both of these tests, were you able to do your blind review and review?
I did my blind review for the Altius exam, but I still have to finish the cars and the chem phys section for the free scored exam.
Yeah. When you say finish, you mean like the blind review part?
Yeah, the blind review part.
Okay.
I don't know. I felt like the car section for that free scored exam like had me floored. Like the first passage, I was like, oh, this, I was so confused. And then I was just like, okay, well, let me skip these questions because I was trying to do the method where we reread to understand the passage, but I just felt like I was losing time. So I don't know. I was so stressed out during that.
Mhm.
It's like, oh,
Yep.
fine, fine.
Mhm. Yep. Yeah, I'll let you know more about why you felt that way. Um, but yeah, I'll let you know after the next test. So, all right, yeah, what would you like to go over today?
Um, like, let me see. I guess I want to go over some biochem stuff just because
Mhm.
I I don't necessarily know like what I'm lacking. Like I don't know. This test has me a little nervous, but I'm trying. I'm like, you know what? I saw this thing on TikTok where this girl was like, "Oh, think of the questions that you got wrong as like things that you could learn, and like this is giving you more information on what you need to work on." So I'm just like, okay.
Yeah, yeah. Like because the fact is that these are still practice tests and obviously while they're meant to be simulations of the actual test, they're not the actual test. They're tests that you can learn from that can then improve your, chances of scoring higher on a subsequent test. But yeah, spending it's more if you have a more process-oriented mindset rather than a results-oriented mindset, um, that could really help you.
Okay. See, okay, I was thinking there's passage 8 on the of the biochem section. The free. Okay, this is the one. Should I share my screen?
Mhm.
Okay.
So do you have the Jack Weston Chrome extension?
No.
Okay. So I would say it probably won't take long for you to download it, but it'll let you see this on in the proper MCAT format where the passage is on the left and the question is on the right. For some reason, AMC doesn't do it that way, but uh, but yeah, I guess we could do that next time. So, um,
Okay.
all right. So, and we've gone over, have we gone over how to like analyze these DB passages and stuff?
No, we haven't done biochem passages yet.
Got it. Okay. This is what we're gonna do. So there's words that I call buzzwords, which are words that, because okay, so it's based on the premise that all of these passages are from like legit, published papers that are written like by and for like PhDs, doctorates and people who are doing actual research. Our job isn't to know it to that extent. Our job is to know it in terms of the basic sciences that we're expected to know. So when we read these passages and we look for uh, the so buzzwords are going to be the words that are on the level of what we are expected to know, and therefore will be they will likely ask you questions on it. So so yeah, I'll have you read out loud and you know, at first I guess I'll kind of like give you some hints as to like what some of these buzzwords could be. Um, but if you see any also mention it when you read this.
Okay. Upon exposure to pro-inflammatory agents such as TNF alpha, cells produce reactive oxygen species. Is that a buzzword?
Yeah, very good.
Okay.
Tell me about it.
Which you said tell you about it? Um, I guess I think it's just it's an inflammatory.
Do like so you probably see this in like healthy food where they say things like antioxidants.
Mm-hmm.
And so have you heard of a free radical?
Yeah.
What can you tell me about that?
Um, I know like I'm thinking about it from like a chem phys point of view, like when carbon has those free radicals every now and then.
So like tell me what is a free radical?
It's a lone, it's just like an electron like by itself.
Yes. So electrons like to be in pairs. They do not like to be alone. So molecules that have a lone electron are called free radicals, and they're super, super, super reactive. And that's why an antioxidant is something that can help perhaps give a free radical an electron to make it, no longer a free radical. So yeah, on the MCAT, they'll typically refer to free radicals as ROS, reactive oxygen species.
Oh, interesting. Okay,
Mhm.
cool. Which can react with guanine bases and DNA to generate 8-OXO-G. This modified guanine can participate in Hoogsteen pairs with adenine, an event that, upon DNA replication, results in G to T and C to A mutations. Guanine-rich promoter regions are particularly susceptible to this type of ROS-induced DNA damage. Um, I guess maybe a buzzword could be the Hoogsteen base pairs.
What's that?
I guess because it's saying it it's just base pairs that aren't like the normal ones, like the G to T and the C to A.
So, sorry, tell me a little bit more.
Um,
Yeah, you said it let you do what?
so yeah, the replication results in the C to A base pairs and G to T. So I guess it's like a mutation.
So, so it seems like they're saying that this Hoogstein base pair is like, so I don't think that's something that we have to like, we're expected to know. I could be wrong, but
Okay.
they're telling us that it enables a guanine to base pair with adenine, right? Which is something that doesn't happen normally,
Yeah.
but I guess then they're saying that a Hoogstein base pair lets something like guanine base pair with adenine, even though that's not, Watson and Crick style.
Oh, okay, I see.
Mhm.
Okay.
And then, yeah, and then the DNA replication, when that happens, it can cause a G to turn into a thymine and a C to turn into an adenine in terms of mutations. And I guess that'll be like a substitution um, mutation. So I don't think it'll affect like, the um, the reading frame.
Okay.
Okay.
So OGG1.
Oh, sorry. And then they say guanine-rich promoter regions are particularly susceptible to this type of ROS-induced DNA damage. Um, so RNA induced. Oh, so I guess they're saying that these mutations, I guess, could occur due to the ROS because they say ROS induced DNA damage, right?
Mm-hmm.
Particularly for the guanine rich promoter regions. Okay. Yeah.
Okay, that makes sense.
Mhm.
OGG1 is a DNA glycosylase that recognizes 8-OXOG. OGG1 is involved in two processes: base excision repair of 8-OXOG, as well as transcription initiation for pro-inflammatory genes such as CXCL family members. Mm, I
Okay.
don't think I
Yeah.
I was gonna say I don't think I've seen any buzzwords there, but I mean maybe base excision repair.
Okay. So now I'm going to show you a way to relate things together using proportionalities. And sometimes people will do it like, if A goes up, B goes down, something with these arrows. But we're not going to do it that way. We're going to do it like the proper mathematic way. So, like, if something is proportional, we're just going to use the proportional symbol. But if it's inversely proportional, it'll be proportional to 1 over something.
Hmm.
So let me see if I can even take it from the top. So they're saying that this TNF alpha is proportional to ROS, right? And this ROS could cause the generation of 8 oxo G, and that can participate in this Hoogstein base pairing, which upon DNA replication results in G to T and C to A mutations. So I'm going to say proportional to, I'll say like G on the top. Oh, wait. I'll do T on the top over G to indicate that if we're going from G to T, we should have an increase in T and a decrease in G. right? And then if we have, and then they say C to A. So what should I put on the top and what should I put on the bottom for that one?
You should put A on the top and C on the bottom.
Good. So we know, like, so now we know that, all right, if you have a lot of TNF alpha, you will have a lot of ROS. If you have a lot of ROS, you have a lot of 8-oxo G, and you'll also have via mutations, smaller amount of G and C and a higher amount of TNA. So
Gotcha.
yeah, so this is going to be very useful, especially when you're dealing with BB passages because there's um, so many acronyms that it's like
Mhm.
pretty much impossible to keep track of. So, okay. So they say that OG1 is a DNA glycosylase that recognizes the 8-oxo G and that it's involved in two processes, base excision repair of the 8-oxo G as well as transcription initiation for pro-inflammatory genes such as the CXCL family members. Um, so I could probably say that the OG1, I could say could be proportional to either repair of the 8-oxo G. It could also cause transcription of pro-inflammatory genes such as CXCL. So in parentheses, I'm just going to put inflammatory. And then they say these transcription events also involve binding of NFKB to promoters as NFKB recruitment increases dramatically following OGG1 binding to DNA. So I could say this could then be proportional to NFKB um, recruitment. Yeah. And they tell us that OG1 is a DNA glycosylase, which would mean, like, what would it do based on that name?
Mm, I'm like, I honestly don't really remember, but I feel like glycosylase, like, don't they like label a certain
So it
part?
so we know it's an enzyme, right?
Yeah.
Because it ends in ASE.
Mm-hmm.
And what does a glyco part mean?
Um,
So like what's glycolysis?
like the breakdown of glucose.
Okay. So and glucose is a type of
Mm. Um, Carbohydrate.
Yeah, right? Or sugar, right? So
or sugar? Yeah.
yeah, so glycosylation could involve so that could be an enzyme that causes sugars to be bound to whatever substrate it's acting on, right?
Hmm.
So, and then it says DNA glycosylase. So it's going to be acting on the DNA, adding sugars to something in the DNA, right? Okay.
Okay.
So, so yeah, with ends like yeah, you want to be very, very, very comfortable with uh figuring out what an enzyme can do from the name of it without having to memorize this is what DNA glycosylase does, this is what, this does. So, yeah, so first of all, you look for, you know, because they're going to talk about enzymes like pretty much 100 trillion percent on these tests. So they usually would say something like, okay, it has these amino acids in its active site, and to examine the kinetics of it, they could change, an active site amino acid to something else. But generally here, like, yeah, I'm not expecting you to know the name specifically of the enzyme, but you should be able to tell from the name, what type of enzyme it is and generally what it does.
Gotcha.
And yeah, and in the last sentence here it says OGG1 binding to DNA. So we know that as a DNA glycosylase, it'll bind to the DNA and then it'll do what it needs to do to add uh sugars. Okay.
Okay. TH5487 is a compound that mimics 8-oxo-G structure and binds to the active site of OGG1.
All right. Right there gave us a really big clue.
Yeah, it's because it says mimics. I was thinking maybe it's an inhibitor,
What type?
competitive,
Yep. How do you know?
because it's binding to the active site.
Okay. And if they didn't say that,
Because it is mimicking the 8-oxo-G structure.
yep. And that's the substrate, right?
Mm-hmm.
So yeah, if something mimics the substrate, it can, and we're talking about, I mean, if something mimics a substrate in general, we call that like an agonist, or we can call it an analog. Um, but in the context of inhibition, we can say yes, it's competitive inhibition. And what can you like? What are some characteristics about competitive inhibition in terms of uh what values and stuff that would change in terms of
Um, so I feel like Vmax would stay the same. It would lower Km.
okay, what is CAM?
Wait, no, not no, it would increase Km. My bad. Km is half the substrate concentration. It's like half of Vmax.
So what is it?
It's a substrate concentration at half Vmax.
Okay, yeah. I like asking that question because a lot of times people just tell me one half of Emax, but it's a substrate concentration that makes it one half of Emax. Now, let me ask you one more thing. Um, so Km, yeah, so that's a substrate concentration to achieve 50% of Emax. Now, if that, let's say, So okay, how can you relate the affinity of the enzyme for the substrate with Km?
Um, the affinity of the substrate for the active site.
Just the affinity of the enzyme to the substrate.
I would say that the
Well, I'll put it this way.
the
If Km goes up, is that increasing its affinity for the enzyme or decreasing?
decreasing.
Good. So Km is more so a dissociation constant rather than an association constant. So it's going to have an inverse relationship with uh the affinity.
Hmm.
Why? So because when you said that it lowered Km and stuff, but then you corrected yourself by saying it raises Km. Um,
Yeah.
if you are basing that just on memory, that mistake can happen. But if you think about it conceptually, you can see that we have to increase Km. We need more substrate to achieve that same level of 50% of Vmax. So that's why it makes sense for, the inhibitor to do that. Okay, great. And then they say that they used reverse transcription PCR and examined whether increasing levels of the TH5487 if it affected the expression of a pro-inflammatory gene following TNF alpha exposure. Um, so since they mentioned inflammation here, um, I know that they mentioned it earlier as well, so maybe but I didn't add it to my proportionalities here, but they do say that TNF alpha is um, pro-inflammatory, and they mentioned this CXL. Oh yeah, the inflammation CXL thing.
Oh
So,
yeah.
if we know that uh, when OG1 binds to the DNA, um, it can cause the initiation of these pro-inflammatory genes, such as CXCL. Um, and now we're talking about, yeah, if this like how that affects it. And like my guess would be that it would lower it perhaps because it would inhibit OG1, and we know that OG1 promotes inflammation, but let's see. Um, okay, next the researchers exposed both wild type and well, okay, I'm gonna just do the figure one first. So figure one, the effect of this inhibitor on pro-inflammatory gene expression levels following exposure to TNF alpha, and we see,
Yeah. Decreases.
yeah, right, we see an inverse proportion here. So now this should make sense because now if TH5487 is inversely proportional to the what is it? The inflammation,
Hmm.
or rather inversely proportional to OG1, and we know that OG1 is proportional to inflammation. I could also say it's inversely proportional to inflammation, right?
Yeah.
So this stuff just helps us look at the relationships between all of these acronyms rather than us you know, having to remember like, okay, this inhibits this, this does that, blah, blah, blah. So, okay, and then they say next, the researchers exposed both wild type and OG1 knockout mice um, to TNF alpha in the presence and absence of that inhibitor, the OG1 inhibitor, and monitored the CXL1 expression levels in figure 2. So let's take a look at that. So they tell us, okay, the presence and absence. So with these figures, okay, just erase that. Okay, so without TNF alpha or TH5487, we have pretty much same levels here between the wild type and the knockdown mutant. And
Hmm.
then if you add this thing here, seems like it produces the same amount also. Um, and we definitely expect that for the one that has the inhibitor, because that would inhibit OG1, but if we don't have OG1, then not going to change. But then here, when we have TNF alpha only, we have a
Yeah.
lot more of the inflammatory expression. Um, and it seems like it raises the amount of this inflammatory expression in CXCL1. Sorry, in this OG1 knockout as well. So that's interesting. And then when
Yeah.
you have both of these, you have so it should make sense that the wild type has a decrease if you add the inhibitor,
Hmm.
but it should also make sense that the OG1 knockout should have no change, right? Because it doesn't because this thing inhibits OG1, but if we don't have OG1, shouldn't change anything, right?
Yeah.
So, okay, so that's what that figure says. And also when you're doing this, like, do you like when you read it, do you like skip the figures or something?
Sometimes. Yeah, I do. I can't lie. I skip the figures and I'll go back if they ask about it in the question. But I've been realizing recently that I feel like I should just look at the figures
Yeah,
like when I read it just to fully understand the passage.
yeah, right. So it's like when you're running, do you like want to like go in one direction, or do you want to go here and then back and forth and
Yeah.
a relay? So that's common. That's what most people do. Um, Maybe I shouldn't say most people, but that's what a lot of people do, but ultimately that's going to result in you having less of an understanding of the passage and ending up spending more time having to go back. And also, if you think about it, like in these types, in like a published paper like this, what's the function of the figures, right? What's the function of the data? It's to it's to illustrate the findings in a way that's easier for us to see. So I would say that on the test itself, spend like 10, 15 seconds to get an idea of what that figure or graph or whatever is trying to say. If it takes longer than that, just move on and, either they'll ask you about it and then you can answer it, or by going back, or, maybe they won't ask you about it, or maybe they'll ask you something really easy about it. But I would still say on your first read to read it like normally, where you look at the figures and stuff, because this way, and it fits in with the entire kind of philosophy I have for the test, which is like you read the passage, you understand it, and the answers shouldn't take too long. Um, so yeah, so I would say that in addition to writing out the proportionalities like I did over here. A lot of people really hate writing stuff down for this test for some reason, but uh, you know, I think that that's not going to work out. So, okay.
Yeah.
So like, Okay, so now they're asking which outcome most likely results from exposure of um, OG1 minus mice to TNF alpha. Um, okay, so, oh, this is okay.
Um, so I was thinking, well, when I look at the graph, um, it stays the same pretty much for the OG1 minus to TNF alpha. Um, but I guess it does increase like slightly CXCL1 expression, which is pro-inflammatory. So I wanted to put B, but it didn't say CXCL2, so I just went with C because I wasn't quite sure. But I guess it's A. I'm like not quite sure how it's A. It's like, is it because inflammation, like, are we just like associating inflammation with cancer?
Yeah, that's pretty strange, but that's this test is pretty strange itself anyway. So let me look at the top again.
Or like this?
Yeah. So let's see. So they're saying inflammatory. So we know that TNF alpha is an inflammatory agent that produces ROS and produces this type of mutation. And then they say that OG1 can cause pro-inflammatory genes to be um, okay. This is pretty tough. Um, because there's nothing that really mentions cancer of any type, but
Hmm.
just from seeing passages that involve TNF alpha and what was the and NFKB
Oh yeah, yeah. Here.
could be something. So okay, let's see. So exposure of OG minus knockout to TNF alpha, and we know that the OG1, like if you had it, it would make CXL or CXCL2, right?
Hmm.
But if we don't have it, then it shouldn't be making that, right?
Yeah.
So we could say maybe that's out. And they also are saying that um let's see, OG1 can repair the 8-oxo G. Let's see.
Yeah, it did say that.
So I think, but if it repairs it, I don't know if that means that it, because we know that the ROS causes the 8-oxo G, and if the OG1 repairs the 8-oxo G, I don't know if that means that it's reducing the ROS levels that caused it in the first place. Um,
Yeah. I
and
think it
yep,
I think it would actually increase it, which I feel like I messed that up.
okay. So, okay, so we can get rid of that one. Decrease in KD of this for its target. Um,
Um, I don't know. That one didn't make sense to me.
So I guess
Um,
they don't have the target anymore, right?
yeah,
Which was
because it's
all right. So now, okay. Seems like it's out of nowhere. Let's see what they wrote. They wrote the passage notes that exposure to pro-inflammatory agents such as TNF alpha leads to cellular production of ROS, which leads to generation of 8-oxo-G. Passage notes that this altered version of G is capable of forming Hoogsteen base pairs with A, leading to mutations within the DNA. Knockout mice would not have OG1 available to repair the damaged DNA, and then long-term lack of genetic stability would increase the incidence of cancer. Okay. I mean, yep, this is a weird test. So, but yeah, kind of seems like a stretch here. There's nothing like really explicit that can tell you. So I would say it's a combination of process of elimination to get your answer here. But this is a tough one because they didn't really tell us. The only thing that they're telling us is that OG1 repairs this mutation of this uh, DNA. And if you don't have OG1, you will not have the repair of that DNA, and that can lead to cancer. So,
yeah,
yeah. So this is a weird practice test in general.
yeah, it's like disrespectful, honestly.
Mhm.
This one I did okay. Let's see.
Based on the data shown in figure 2, what are the effects of OG1 and TH5487 um, on CXCL expression? So if this is the inhibitor of this, they should have like opposite effects, right?
Yeah,
Okay, let's see. Roman numeral 1 says OG1 reduces the TNF alpha induced um, CXCL1 expression. What are your thoughts on that?
I don't, I don't think that's the case.
Now we could use this over here, right? Because we can see from this that OG1 here is proportional to CXCL, right?
Yeah, it increases it actually.
Yep. And the opposite for the TH thing, right?
Yeah,
OG1 reduces, so that's out, right?
and so I think it might be two. 'Cause yeah, it stimulates the
Stimulate
CX.
the expression. Yep, we see that. And then 3 says that the inhibitor reduces the OG1 making the CXCL expression. That's true too, right?
Yeah,
Then the last one, it says that it the TH thing stimulates the CXCL, which is out, right?
yeah.
So
So
one out, yeah,
I was thinking, yeah, I would definitely be two and three. I feel like I just got floored by this passage, so I kind of gave up. I just
yeah.
put A.
There's lots of acronyms, right? Like a ton.
Yeah,
So that's why writing out the proportions like this is going to really help you because we get this like we don't even need to care too much about like what these mean exactly. We just know if you have more TNF alpha, you have more ROS. If you have more ROS, you have, the 8-oxo G. But if you have OG1, you can have more CXCL. And if the TH5481 is an inhibitor of OG1, we can say that it's inversely proportional to OG1 and inversely proportional to the repair of 8-oxo G, inversely proportional to the CXCL being transcribed, and inversely proportional to the NFKB. So writing out a proportionality like that is going to be really, really helpful.
Gotcha. So I'll do this like within my practice as well.
Yep.
Just write out my proportions. Yeah, because I definitely feel I see it just helps a lot because then I won't have to go back to the passage as
Exactly.
much.
And that fits in with the overall like philosophy of like you read the passage, you look at the data, you get an understanding of it, and then you can move on with that understanding of it rather than reading part of the passage, reading the question, going back. Because that, in addition to taking up more time and being more distracting, will get in the way of you having a kind of holistic understanding of what the passage is trying to say.
Gotcha. Let me see what I put. Here's this one. Got so many wrong. Um, this is researchers measured the NFKB occupancy of the CXCL2 promoter following exposure to TNFA, both in the presence and the absence of TH5487. Based on the data presented in the passage, which figure depicts the expected results? So I was kind of confused because I was like, why is it talking about CXCL2 when it was talking about? I guess it says family.
Oh,
I
because
thought
it's
it was, yeah, I thought it was mainly talking about CXCL1.
yeah, I see, I see.
Um,
Go up again. Let me see the. Okay, so binding of these to promoters. So to, I'm just going to add promoters here. But yeah, I think we could answer this based on our proportionalities. So let's look at that past the question again. So, okay. They measured the NFKB occupancy of the CXCL2 promoter following exposure to TNF alpha, both in the presence and absence of TH5487. So this means that in the present, so first in the absence, it's going to behave the way that we see OG1 behave.
hmm
But in the presence, we're going to see the opposite, right?
right.
We're going to look for something that has um like no TH5487 being different from having TH547, right?
Yeah.
I guess all of these have, well, wait.
Well, this one didn't. This first one.
Okay, yeah. So, okay, that's out. Now, if we look at so I guess what we will be expecting is that without, so like TNF alpha, like is gonna like be there regardless, but if you don't have it, you have OG1, and we know OG1 causes the NFKB recruitment to happen.
Yeah.
So we should see for TNF alpha only and no TH5487, we should see a higher amount of NFKB occupancy, right?
hmm
And then with the TH5487, we should see a comparatively smaller amount of NFKB occupancy, right?
Yeah. Because it's doing its inhibitor job.
Yep. So that'll just be C then.
Yeah. That makes sense. I'm like, okay.
Yep, yep.
Now that I understand the passage, LOL.
Yeah, yeah, and you see how when we wrote this out here, that's all we needed to really consult as we answer the questions. So, and writing it out this way is going to be super, super helpful. Like just straight up in general, like for instance, like a real lot life kind of thing is like I'm thinking of like in a stock market, like the price of stocks are inversely proportional to like the price of gold. So if stocks go up, gold goes down. If stocks go down, gold goes up. And it's just useful to think of it in these terms. Now, some people do this arrow thing, but that doesn't give you insight about what a graph of this might look like. Because what do you think it'll look like?
Um, it would be like a negative line, I guess.
That, right?
Mm-hmm.
Now, we did this properly, like this. We could see that this number cannot be zero.
Yeah.
And that means that at these axes, you have asymptotes. And the larger A gets, yeah, the smaller B gets. But if you plug in numbers, like let's say A is 3,000, this will be 1 over 3,000. So it does get smaller, but it never reaches zero. So the curve
Right.
looks like this, right?
Mm-hmm.
Not like this. Okay. And, that's something that they like to test. So I would be aware of that. Because, I mean, it's logical for it to look like this, but it doesn't. It really looks like that. Okay.
Gotcha. Mm, well, I mean, can we go over the first card's passage as well?
Oh, I don't think we have time for that because we just have an hour for today, right?
Oh, okay, gotcha.
And I just have another student in like 13 uh minutes, but I mean, I'm pretty free during the week. Do you want to meet sometime tomorrow?
Um, because I have work tomorrow.
Yeah, or like Wednesday, Thursday, Friday, anything like that.
Okay, wait, let me see. What times are you available?
Um, I'm pretty free, so like well, yeah, tomorrow I am pretty much free the entire day except for 1:30 to 3:30 p.m. Eastern. Um,
Okay.
yeah.
Maybe we could do tomorrow at like 6, possibly, or because I'm like I was gonna ask like what do you recommend for my studying just to make sure that like I'm improving. Like, do you feel like the miles down review sheets are do you think that they're thorough?
When you say the review sheet, you mean the like the large quick sheets?
Yeah, it's like 100 pages.
Yep, yep. There's that. There's also a Jack Weston quick sheet that I put in the drive. You're asking if that's a good resource to use, like in general, or
Yeah, I mean, because I feel like there are things that I'm missing in the biochem section and slash like psych soc and I just don't want to waste any more time. So I'm like, should I just work on like understanding all the content from there, or I don't want to make sure I'm like not missing anything is what I'm.
yeah, yeah. So you could use that. There's a Mr. Pankow deck, which is really good for the psych soc. Um,
Hmm.
but I would say like after every practice test that you take, you're gonna add psych soc terms to like your notes or your Anki deck or whatever you like to do. Because there's going to be essentially no limit to what they could ask you for the psych soc section. So you want to be learning every single step of the way. And that means like even if you got questions right, if there's terms in the choices that you don't know, you want to look up those terms. So psych soc is going to be a constant learning process.
Gotcha. Okay. So I'm like, well, maybe we could do Thursday around is 7 too late on a Thursday?
I have someone Thursday at 7.
Oh, okay. Hmm.
But did you say something about 6 p.m. tomorrow?
Yeah, that could work. Yeah.
Okay. Okay, so I'm putting you in for Tuesday the 6th, aka tomorrow, at 6 p.m. Eastern, okay?
Gotcha.
All
All
right.
right.
I forgot, wait, like what was the rate that we did?
85.
Oh, okay. So, yep, you can send that in.
All right.
Um, and I will see you on I'll see you tomorrow.
All right. Have a good day.
You take care.